Okay, so how does a Rose engine work? The principle is relatively easy. There's just a lot of those discs here that are called Rosettes, so that's why it's a Rose engine, and they have different patterns.
Well, that's the neat thing about this.
Okay, so
So we had, you put the thing to it, and all of a sudden it would jump away, or you didn't have the head tied down properly. And this I discovered that the indexing wasn't tight enough, and it would rock in the indexing. So we put it flat on the indexing to make sure it was solid. So by the time we did this one,
The indexing should be jammed under the chuck.
available online. So basically, it's his name is Jon Magill in the U.S. He has designed an MDF Rose engine just to make it much cheaper than all the metallic or other ones that range from, I don't know, 20, 30,000 up to 200,000 US dollars, and you can have a very beautiful machine. And that's not an antique, so that's a newly built one. So they exist, but you know, you have to really like it to get there. But this one here is much easier to do. So all the MDF parts, I mean, you buy your sheet of MDF and cut it out, and then there's a few metallic parts in there. So I decided to buy them from him, which is just easier. But you can also, if you want, at least for that version of the MDF Rose engine, they're available online, so you can machine them yourself, and some bits can just be bought. I mean, when you buy the kit of all the smaller fiddly bits, so all of these little tracks, then that all comes with it. So, but that's easy to do yourself if you have to. Okay, so how does a Rose engine work? The principle is relatively easy. There's just a lot of things you can change and adjust and vary around. So basically, on a normal lathe, you have your piece is turning, and you use the chisel that's fixed and try to shape it. Whereas here, your piece of your project is basically, just use one of those here, is basically fixed, and the cutting is done by the fly cutter that's rotating here. And then to get the shape, just do little ones.
That's a dinky little chuck. Where did that come from?
From the chuck shop. That one I got, I think it's in the US, I don't remember which brand sells I think that's the smallest I could find. But in the meantime, I saw that Record also has a small one.
Yeah.
So, but you don't have to have a small one. It just, the spindle here is a 1-inch 8 TPI shaft, so the same as the Comet lathe. And I have all my chucks are for the DVR, which has 1 1/4 inch. So rather than playing with adapters and whatever, I just decided to get a chuck for that. And then it doesn't need a big chuck for that, so I decided to buy a small one. And that has a dedicated, it comes with a 1-inch insert, and I think there's even an insert for something smaller, for even smaller mini lathe. Yep. So basically you fix your piece here, and that's on a rocking head. So if I pull that one, so basically that one here, that can move like that, and it turns at the same time. here with my handle, so I can turn it slowly by hand, so it turns very slowly. And then the cutter comes and does what the cutter does. And why it is a Rose engine? Because then you put those discs here that are called Rosettes, so that's why it's a Rose engine. And they have different patterns around here, so I have a number of them. So I think this one, and that one are the two original ones that I got. So that one is basically a square, so you can, if you put that in and at the right distance, and it makes a square on it. Also, it's not entirely square, but that's the result. It's one of the mysteries of a Rose engine. That's not always exactly what you have here that will show on here. And that one is, which one is, oh no, that's the D, so that's not the that original one. Yeah, this one here, the sine 24. So that's a sine wave, sinusoidal wave with 24 bumps all the way around. And so I think I have a few of those with less or more. And the square, that one here, well, that makes you a snowflake, believe it or not. So it has a pattern that just makes, that has, there's eight points. Yeah, and then that's the plane that's makes an hexagon and so on. Yes.
So where did all those come from?
So those ones I bought, but I mean you can also have them make them yourself on a CNC machine or laser cutter maybe.
But if you make them yourself, you have to know how to interpret.
Yes. So all of that. I mean, the Rosettes has been around for a long time. Because that's something in the, I don't know, 19th, 18th, 19th century when it started. And there's books that are available that gives you all the diagrams of any. And the guys who did that at that time, I mean, they had hundreds of them made out of brass, and there was no CNC at that time, so they were all handmade to make them accurate. I don't have, there's a few plans around, I think, for a few of them, not all of them, so we probably can translate them into CNC file. Okay, so well, we can put this one back out here. So what let's do, maybe before cutting anything on that. I made a little disc here that, because the problem is to figure out what shape, what pattern you're going to get, and made a disc here that we can tape on some bits of paper. Square. And these ones here are not flat. I have some square ones in there.
On each rosette Holm, there's a series of small drilled holes.
Yeah.
What do you use those for?
Well, I'll show you when I make that squarish. Took my double-sided tape out. But
Is it the what?
Oh, under the thing there. There we go. So let me just put some of that in there. They used to have a spray but that kind of messes up everything, and it's a bit hard to get it cleaned up again.
The Americans seem to make pretty little frames to mount.
Yeah. Oh, yes, you can.
To mount your paper and for testing.
Yes, maybe I should do that. Yes, you can.
Frame
For,
it over.
yeah, and you can buy it, and it's $250 for the little frame for the.
Yeah. I've been watching too much of the stuff online.
Yeah, I'm not sure that's gonna stay on, but we'll try anyway. So I will have to
That
clean it up one time.
blue thing that you've got there, is that metal?
Yes. So that's that was my improvement. Initially, I didn't have that, and that was on a bigger board, and I just clamped it down.
Yeah.
And then it only happened once, and it happened here. So I pushed it out a bit too far. And forgot to clamp it, and the whole thing fell down. That's why the thing is bent here.
It did make Terry jump.
And Terry was sitting there, right in front of him, and the whole thing, and everything was attached, so the whole thing fell down, and that's the only thing only damage was that was bent, because it's quite heavy, so that's not going to go anywhere. Okay, so you can take that. Right, put it here. Just to show, put the. So we have the rosette, and the rosette basically rotates, and there's a rubber band here that pulls it back, and I have here called a rubber. The ones I have here have a little bearing at the end, but that's basically a simple one, and the rosette basically is going to rotate against that, and that's going to make it rock just a tiny little bit. And the system I have here is a double one, so that you can actually put two rosettes and combine them. So I hope that turns kind of. No, take that away. So one thing to try to do is to keep it roughly in the middle, not that it's rocking on one side or on one side, but keep it in the middle. Just kind of have a repetition of the shapes, and so you can, let's see if it works. Let's see if my pen works. You can see the little bumps that it does. So it's, I slipped a little bit, so it does that. So it gives, so you see it makes a very fine pattern. So, but if you put that on a round surface and keep cutting it all the way around, and move the cutter bit, cutting it around again, so it gives you little flutes or little lines. So it's all relatively small. So one first thing to realize is that you can cut on that side, on the front of the ice spindle, or you can cut on the back. So so if I do that here. I'm not sure how obvious it's going to be with this one here, because we'll have to probably change. Oh yeah, yes, we can see the difference. So if you look, the pattern is different. So on the front it made the bumps like that, and the other side it made the bumps like that. So depending on where you put, so that's the first thing that you can play with is cut there or there, so it gives you a different pattern. So. And so that's the start of that. So basically, if you want to do, what do I have here? Something. I have something. That's hard. So that's a combination of a few, but basically you pass it around afterwards. So those flutes here that go down here. So basically you use the cutter, and then you go all the way around, and then you move the cutter a little bit and go all the way around again, and so on until you have the kind of the length that you want. And the same on top here, that's made with the square, the square one here. So it cuts those grooves. So you put the cutter on one side and then move it a little bit until you get the whole pattern or whatever you want. So you can see there's a lot of manual work. I have a lot of them, so all sorts of Okay, so that's the first thing. So then the next thing is what's called fading. So that's basically how far you want it to rock. So I can, for example, so I'm just going to change it to the square one because that is going to be more obvious. I think that one is just what I used it last time. Huh? In here. There you go. So the square one's a bit more obvious because the movement is a little bit bigger. So first we can just check what it does on here. So yeah, so it comes out roughly square. So if I move it smaller, it's going to become closer to a square. So the fading. So basically, how much it rocks, I can block it off and decide that I don't want it to rock the whole distance. So
does that mean it's going to clear here and there? Does that mean it's going to clear here and there?
Yeah, so if I use that one here now, so it should just have a little. It's again, it's very faint, but so if you compare the first one inside, that has the original shape. This one, basically when I block it all off without touching that, it's making a circle.
Yeah.
So basically, that has a circle with a little point there. So you can create effects like that by just blocking off how far it rocks. So usually I kind of just keep it off. So that's fading. So the next thing we can play with is that's what you asked, John, is those little holes here. So if I take this one here as example, so if I have it turning and then I just shift it halfway, then I shift my pattern here. So I shift, instead of having the points here, I'll have the point in the middle. So without moving anything here,
And you are in control how much you shift it by.
so there are different levels. So I've written it on here. So that's 1/8. So there's 8 holes. So you can do it half, quarter, and an 1/8
Sure.
movement. The other ones that are a bit smaller here with the 30, it's only have half and full, so it can only go on the top or shift it by half of the distance. So there's only 2 options. This one here has 4, so I can do up to quarters and so on. So if I
So you
move
can
that one,
offset it by 50%.
so if I offset it here by 50%, so and that I've removed that. So let's go just to the inside here. It's stuck, the paper is stuck again. Yeah, so you can see when you see it's offset halfway. So that can create some. So that so you can create patterns like spirals and so on. So I think one of the ones is around. So yeah, the one with the things on the side.
Yeah.
So that's I'll just. So if I thank you. So the one where I have done the cuts on the side, so half are there, and then it's offset by halfway, and so you can create the pattern, or that one here that makes like the brick effect. So I just cut it and then shift it by 50% and did the next cut and so on. So as you can see, I missed, or well, no, this one is not too bad. It's two bigger ones, two medium ones, and two small ones. But I think I have one where I missed. I didn't count right or measure right, because you have to go exactly the same distance to make it look good. Yeah, so that's that. And now, in addition, we can put two of them on. And then that's when we can make things like the. And then I think after that we'll try to do one with the laid on.
They take over from each other, do they?
Hmm?
They take over from each other.
Yes.
Yeah.
So depending on how. Have that. So that's a bit fiddly because you need to. Little ones.
That creates a few possibilities suddenly.
Yeah.
Thousands.
So the challenge is, of course, to figure out what everything does, and then repeat it.
You've got to take note of it.
Make again the same, because how you make notes, yes, but how do you want to take your notes? I mean, you can write down which rosettes you use, but then how you face them or whatever, it's not.
How you phased, how you moved the cutter, which cutter you were using,
Yes, and
how far the cutter was out.
It's a few variables.
It hurts.
So that's when I can use my double.
So it's every time a surprise what comes out of it, is it?
Well, I mean, with a bit of trial and error, you can
Predict.
you can predict a little bit. But let's push this one in a little bit more.
So how many of your rosettes have you fully explored?
Really explored those two, and I've tried out some of the other ones.
Yeah.
So I have.
No, it just strikes me once you've got about a dozen rosettes,
So I've.
and you can combine them.
So
And
all
you
of
can do all
those.
these different things with them.
All of those rosettes. There you go. You can read the construction instructions. If you want. And then I printed all that. No. Maybe I didn't print. Oh, yes. So that's some of them. Oh yes, that's. So they all have different names. So that's the D30. So the D shape is basically like that with a point at the bottom. So that. So D30. So that's kind of the pattern what we did here, kind of what it does, and that's kind of the patterns that you kind of can make with that. F4, just that kind of stuff, you can make something like that. So F4 is somewhere in there. F4. So F4 is basically like a D, and then it has a little bump here. So it allows you to do that kind of that flower pattern and so on. So I think I printed it. I think they're all of them. And that's F1, makes you a little heart. This one here already looks like a heart, so that's a bit obvious. So there is so when I did that, that was all done by Jon Magill, and he had those documents on his website. In the meantime, he's stopped doing that, and somebody else has taken over. It's Colvin. I'll look up the website, Colvin Tools, and he has made a version 2 of that now, which is still very similar. I think it's a bit higher. It has a longer spindle, and he has designed a few other attachments that you can put on there. There's the pumping system, so that moves the thing in the axis direction. An amplifier, which makes those movements a little bit bigger, a little bit smaller. So another variation, and I don't remember several others. And the other thing that he's doing is that he has a motor for that. There's no more handle here, so there's a little stepper motor that you can turn on, and it just turns the thing slowly, which is quite convenient. That's a bit the tiring thing to sit there. Yeah, and on his website he has all of those Rosettes and all the examples like that. That's from the website, and he has also links to all some of the historical books on how that's all has been developed, and I think some links to all the cutters. Because the one I have here, that's just a horizontal cutter. You can have some that are just like a router, and then you can have an eccentric one that's probably similar to what you have on the Techno tool, the Nova Rose engine. So that's a cutter that cuts your circles. So you can cut circles combined with movement. So never ending. Okay, so let's see if I can make one. Something happened here.
You taking more on this? Yeah.
I can feel some sort of mental paralysis coming on here, where you just can't decide what to do. Too many options.
Too sick of me.
Yeah, but you don't know. That's homework for next week. Build one. For next month.
No, I want to know the geometric difference between having a rock versus slide. Because some of them slide side to side, and that one.
Yeah,
not
that one
rocking
slides,
as
I think.
such.
I mean, it's
How-
such a
how
small
much does
movement.
that-
It's such
yeah, I
a
don't
small
know.
movement that I think. I mean, the sliding one, it's a bit hard to
Yeah.
make it work. It requires probably a bit more force if it's not well lubricated and on bearings and everything.
Yeah.
Whereas that one is just on two.
On a pivot
Pivot.
makes a lot of sense,
Makes it
makes it a
easier.
lot easier to build.
And I think the original Rose engines, the Holzapfel Rose engines, they're all rocking heads.
Oh, okay.
So I think it was also because it was easier, and I'm not sure they had bearings at that time. Probably not.
Well,
it was
I
all
think with
brass
the,
and well
with,
lubricated.
with the speed that it's going,
Yeah.
brass bush would be
Yeah.
perfectly adequate for
Yeah.
most
Yes, it's just the cutter and so on.
because we're not spinning at 5,000 RPM like we are on our normal lathes.
No, but it's going quite.
Oh, the cutter.
The cutter is going quite.
Yeah.
So the first thing to look is that kind of the cutter clears before turning it on, and we can see if it. So it's turning, and it just keeps getting closer. And it stops turning. you can, so that's the combination. You can see that a little bit in the middle is touch on the sign. Something is a bit stuck, so I should have checked that before. Anyway, so we can turn it off and have a look. So that's basically the same as the outside of that. So that's basically it, and then you can just keep repeating and keep going. So when I was in touch with Jon Magill and asking how many rosettes do you need and so on, he said, well, that's from his one of his articles in the American Wood Turning magazine, and all of those 9 are made with those 2 rosettes here. Nothing else. So he said, well, first figure out how to make that, and then you can.
Did you make your own fly cutter?
Sorry?
Yes.
I think these belts were slipping.
Yes.
There's
No, it's the.
It's not tight enough.
Yeah.
Neither is this one, I think.
But that's the elastic just to.
Yeah.
But this one is easy.
This
to,
belt's turning, that one's not.
Yeah. So this one is easy just to.
You can't do any damage with that, but it stops.
Yeah. I think they're tight. They're tight enough, but it's somewhere. It's for me to take it out and lubricate and go clean it.
Yeah.
It's just a bit stuck.
Oh, tempted to tension it a bit better.
Yeah. I mean, I've used it like that now for a while, and
It's awesome.
Yeah. I mean. Oh no! You know what happened? I tried to lubricate that, and I think
You've lubricated the belt.
The belt, so
Yeah.
now the belt is slipping.
Yeah.
Yeah. So of course we'll have to clean that out. Yeah. So the cutter. Yes. So I made. So I mean the cross slide table. That's from. I think I bought that from Chefback. Has the smallest, because the problem is I wanted something that's not too high. You can find quite a lot. I think even the ones from Machinery House, so they're all a bit higher. So that's the smallest I could find. And you want something that's solid enough and has not too much backlash. So when you rotate that, it stays in the same position. I don't want to go too far in there. So
You don't lock anything in place.
no, I mean that's locked, but then this one here you don't need to lock them. They're not moving away.
So that cross-slide vise was designed for a very small metal blade.
Yes, probably. So yeah,
What sort of cost was it for that?
I think that's probably the most expensive part of the whole thing.
But the cheap versions.
Well, you can get cheap ones for $100 or so, but they're aluminium and they're not. They tend to bend a little bit, so I don't remember, but it's probably $300-400 that one here, or something like that. And then you have the tool holder and whatever comes. But I mean that's just the same as for a metal lathe. And then so I can take the cutter out.
So the tool holder could be replaced by any piece of equipment that turns and
Yes.
pulls around that rotates.
Yes, I mean.
The router.
Yes, I mean you can hold your tool any way you like. I think the cross slide is good because you can make finer adjustments, and then the tool post. Again, you need one that's not too big and allows you to go down. Because this one
you could clamp directly to the.
You can clamp it directly onto there. Yes, I mean that's.
If you want.
So
I can see why they've gone for tall posts in some of the designs. It's because they're running 3 or 4 different cutters and then we'll swap them out.
Yeah, and I mean I
What's wrong
can.
with the router then?
Yes, I mean right now since I only have one cutter.
Routers only do a point cut, whereas this is actually cutting in Because it's actually, the cutter's actually horizontal.
So I made that, so
Yeah.
basically I had a square bit of aluminium, so I turned that one down and then I made a little disc at the end. So this one, in addition to turn horizontally, I can turn it like that and it cuts vertically, or it can cut at an angle. So when I did these ones here on the side, so these ones here are cut with horizontal cutter, and this one is cut with a vertical cutter. So yeah, there's a lot of, and this one here is the round shape. So I have a number of different ones here. This one is just a point. Then it's square, so that's a square cutter for making like the brick effect. So those I got them from the US. There's a guy in the US who only makes cutters for Rose engines. So that's his hobby, but he makes that, and he doesn't make anything else. Just makes those cutters.
And so what diameter are those cutters?
What would that be? Three millimeter. Yeah, 3 millimeter, which is it's 1/8. So yes, it's close enough. Yeah, it is probably 1/8. It's not 3 millimeter. Yeah, and then I mean I made the little brass bit here. And so you need to make the hole for the cutter and then make the hole across for the grub screw. I followed the instructions on that. They said put the grub screws on both sides just to balance it better. But then I mean the cutter doesn't stick out, so it's still not all the way balanced. But maybe that's better. And then those little wheels here, I turned them on a metal lathe.
That's a beautiful little piece of equipment you got there.
Yeah, so that, and then those bits here, I mean, you may just make them in. But I basically followed the instruction. I think this one here has two, I don't know how you call those pins in there to line it up, and then just tighten it with a screw. Bearings, just have to see what bearings. In a minute, too many papers here, but yeah, I mean, there's a universal cutter frame, so that's one bit, and then there's all that's, I don't remember which part that is, and so on. There's all, I have to kind of, so yeah, so that's what it's supposed to come out like, and that's the one.
You can download this?
Yes, that's all available somewhere. I mean, I didn't make the drawings there.
No.
Yeah, yes, but I mean, you can download them and then get the measurements.
Do you need to lubricate the spinning part?
It has bearings, so and they're you need to get the ones that are dust proof.
Sealed.
The ones that are sealed well enough.
You supplies the belt?
And the belt, you can make the belt. So basically, to make the belts, you buy. So if you want to change color, you can change color and you make a blue one. So basically, to make the belts, you take a little cutter blade you don't have it here in a vise. It's not going to stay, but hey, cut myself with it. Well, suppose it's in a vise, then I have my burner. Make it until it's hot, put it on both sides, cut it nice and flat, and when it's melted, just pull it up and push it, and then squeeze it. Squeeze it a bit.
That's what I did this afternoon.
Squeeze it a bit with your fingers, and you get a little bit burned or not.
Yeah, you do. Yeah,
and I tend, before it cools down, I just rotate it a little bit so that it
And
makes
then
sure.
it is
Because when you
vertically,
look at it from that side, obviously you line it up vertically, it's aligned, but horizontally it's not. And
Why didn't you tell me all this morning?
but then there's people who make
did you jump the
little
gun?
jigs to do. There's people make jigs to do that with just two holders on each side, and then they're slightly spring loaded, and then just you heat it up in the middle, pull it out, and it just
How many hands have you got?
Hmm?
How many hands have you got holding the thing there?
No, this one is in a vise, and well, you heat it up when it's red. That's okay. It stays red a little while.
No,
It's
no,
okay.
just hold it with those two fingers.
Yeah, but you have to hold it,
Somehow it happens.
and hold it, and then you measure it, and then you realize that your belt is, 2 millimeters too long. So you have to cut it and do it again.
Yeah,
So until it's, and it's better if it's a little bit too small, because you have to tension a little bit. So that's why those little ones, that one that's around the cutter, I have a few, and they tend to wear. And
has anyone tried using conventional V belts instead of these types of belts? Because they last a hell of a lot longer.
The radius for you'll find is too small for the belt to follow.
Yeah, I mean there's things like the radius, so you need to look. The thickness depends on the radius that you want. So for the cutter, you need relatively small ones, but still they need to be strong enough. And
This belt material was well proven in the industry.
I mean the belt. I think the V belt also with like this one here that bends in several directions. I mean a V belt wouldn't work, but even for that one the V belt doesn't work. For that one, yes, that would work. I mean, you can even have one with like the timer belt.
Yeah,
with
the
the,
technique to put a
so
timer belt on there, so it
that would
doesn't
work.
slip at all.
Doesn't slip. But then you need to make the pulley here with the proper. Have the right pulley. I mean, you can buy the right one and put it in there. So yeah, I mean, of course you can. There's many options. I think that the idea for this one here was just to do it yourself. So all those pulleys, I've turned them on the lathe on MDF. So you just turn them and then put super glue on it, soak them with super glue so that they stay hard enough. Or here there's a little grub screw in this one, so also you cut the thread and put some super glue in it too.
You could probably cut instead of a round groove, you could possibly machine a V, and then it will sort of jam in there and be more grippy.
Yeah, yes. I mean, that's the first time I have really the problem that it doesn't work. I think just because it's too cold, the shaft at the bottom got a bit too tight, and then since I decided to lubricate it and lubricated the belt, so of course that's. So yes, and then you can start playing around. You can make some plywood. So that's what we did here, the combination of the square one. That's easier to see. I think that one is the, I'm not sure if that's the snowflake or if it's not, probably not, but yeah, I mean, you can, and then you can, you don't have to make it on flat, you can make them on a little ball and make it inside and outside.
Now you've lost me.
Inside and outside.
Definitely lost me.
Yeah, I think it's time to get the other one going, and then.
And now see if it gets going.
What's this one?
Stop worrying so far. I'm stuck.
On the ratio from your motor to the end tool, was that 1-to-1? Or does it go through bigger pulleys, smaller? I guess what I'm trying to say, what's the...
That's 2.5. That's 2.5, and that's 3.5, so that's slightly bigger, so it's increasing the speed
Oh, yeah.
a bit. And the smaller one here is I think it's the same, it's about 2.5. But I mean, I just made two different ones, but they're not that different, so it doesn't really make such a big difference.
And what's the RPM of the motor?
I don't remember. Whatever it is, and then I have a speed control here, so I can turn it up and turn it down.
So you do it by ear?
Yes, and see if it.
Sounds like a dentist is good.
Yes, and so this one here is the one of those that's kind of rotating here, trying to do that. So with you can make things like that. You have to. I found that it's better. The faster is better, just because it cuts better and it comes to the wood with a bit more speed. But it's a combination of, I mean, it depends on the wood, how hard the wood is, and then how much I mean, the feed rate, I mean, how much you get in and try to cut out on one cut.
Tip that blade before you cut your arm.
Hmm? Yeah. Yeah. So you can be a bit too aggressive, and then all of a sudden, but then it just stalls the cutter, and the cutter just stops, and then you just realize, if you realize it fast enough, you can wind it out. And I think that the belts don't like it if they're
Sitting there.
if they sit there, but it's.
Only like this.
Yeah, so you just line up the cutter so wherever it works. Yeah, so that's why it's quite narrow and small, so you can go inside. So I can, if I have a box, I can go inside and cut all the way along the one side.
That's a big reason to keep it
for
small.
that depth, so you can make it longer. Yes. Yeah, so that I mean, if you cut only in front here, like on lids, I mean that's easy. You can make something that's quite small and stocky, but that one allows you to go a little bit inside or behind. But I mean once if you have fun making them, you can just make another one for whatever special use you have.
Yeah, of course.
The maker of our Rose engine obviously had a bit of a thing about wiper motors, because there's several there. Is there a reason why you didn't use a wiper motor?
For what purpose?
But I mean, the wiper motor is probably just for turning
modern age, we wouldn't use a wiper motor, we just chuck a sticker on it.
No, but it doesn't
Back when you
need to
built
be a
that,
stepper motor.
wiper
That's
motors was
what
what
is-
was available.
The wiper motor is only to replace what he's doing there back
Yeah.
then.
Yeah, I mean, you don't need a stepper motor, but I got the bit to replace that by a motor, but that comes with a stepper motor, so I just use what somebody else has designed, and all the electronics, it all works.
Yeah, walk away.
Yes, I mean, you can do that, and then you can control that here with the computer, and then it becomes CNC at some point.
Yeah.
So you have to kind of decide how much. Where the limit is and where your fun is, but it's the same as on the
If
lathe.
you want
And
to see the other extreme, which is approaching CNC, look up corn lathe Bill owns online.
yeah, but I mean, he does it.
Yeah.
It's still a Rose engine, and but I mean, even the Rosettes, I mean, the movement there, you can control that with a with a stepper motor, and
he's taken the next step in that he's actually running it on a normal mini lathe.
yeah,
So there's no rocking in the lathe
Yeah.
itself.
yeah. But then you can replace that, but then you don't have to make it round or symmetrical. You can, and then you have a 3D carver, I mean a CNC carver. I mean, you can. So it depends what people enjoy.
Hmm.
And I think I don't think there's any money to be made in doing those things here. But I didn't bring the magazine. No. Well, another time. There's a Society of Ornamental. There's different organizations. There's Ornamental Turners International. I think that's a U.S. based, and that's the guy who is currently maintaining the plans and all the documentation for that. So I think it's also associated to the AAW, but so they have a whole. You need to become member for, I don't know, $30–40 or so a year, and then they have all sorts of documentation on projects and tools and whatever. And then there's in the UK there's the Society of Ornamental Turning, and they have a lot. I mean, that has existed a long time, and they have also collections of pieces of art. I mean, that's the old ones were made in ivory, so they made big. It was the toys of the kings. Probably the king was saying, "Do that," and then somebody else was doing that. But I mean, there's amazing projects to do, and it's incredible what can be done. But it takes a long time. So, yeah. Well, I mean, that's about it. I mean, the other thing is just to watch me see and turn the wheel. But yeah, probably have to clean that out first to make it. So if you want, you can do this time. You can look at the other one. Yes.
So do you have any plans to further develop?
I got the new. So the difference between this one and the version 2, that's the current one, is basically the shaft is a bit longer and it's higher. So I might redo it with the. I got the new shaft, and it's a shaft. So this one here has the 1-inch thread, and the new one he has a Morse taper, because it says it centers better. It's more accurate to center it rather than the. So and it has a spindle that fits into it, so you can take your chuck out with the Morse taper and put that on your lathe and turn it and then put it back in without changing anything. So it's more accurate, because I mean if you just if you cut away all the surface